Hi, how are you? Very good, very good. We are very happy to be here, and this is the session, Build Resilient Systems with Spring Cloud Contract and Test Containers.
Thanks for coming. We need to show you this disclaimer.
Yep.
Yeah.
Very good. Right, so what is going to happen in this session? In this session, we're going to look at a couple of technologies, and the main topic of the session is the testing your applications better. There are different types of tests how we can run, and the contract tests is the types of tests which will help you specifically when you need to run your application and verify that your service and other people's services or other services by you work together well. So they speak the same language, and that is what is typically solved in the industry with the contract tests. We're going to use test containers to provide some parts of the setup, and we're going to talk about test containers, and we're going to have two applications there. We're going to run the tests. We're going to give you the the notion of what concepts you need to know to be effective, to maybe learn about this further, and it's going to be fun, right? So, without further ado, please welcome Olga.
My name is Olga Maciaszek-Sharma. I work in the Spring Cloud team on various Spring Cloud projects that are listed. And I also work for GraalVM native support for Spring Cloud projects. These days I also work on Spring interface clients. But what is important is that I probably was the first user of Spring Cloud Contract and one of the first contributors. So yeah, I hope I can show you a thing or two about it.
Right. Perfect. Olga is a true professional. My name is Oleg, and I work as the developer advocate for the company called AtomicJar. This is the startup made by the maintainers of the Testcontainers libraries. I do contribute to the Testcontainers libraries, mostly in Java. So my list of projects I contribute is much, much smaller. But nonetheless, today we're going to talk about contract tests. So for that, we need to understand the setup that we're going to work with, and it's going to consist of two applications. They're going to be two microservices, a waiter application and a barista application. And those two services are going to talk to each other. They're going to communicate via a message broker, via an Apache Kafka. And normally, they could do other setups as well. Like you can have a direct HTTP call, or you can have a gRPC call. But for the demonstration purposes, conceptually, it's going to work the same as contract test is going to work the same as if there was a direct call there. But to show you that it's not just for when a service calls some other service via HTTP, but the approach supports more complex setups. We're going to talk via Kafka.
Yes. So let's imagine that we are sending messages for our application, and we are going to take orders from waiter. The barista will prepare servings and send on these servings, in this case, through Kafka. So obviously, we will have some kind of topic that we need to send them to. That's important. We have a certain body that we need to be able to serialize, deserialize on both sides. So the consumer application and the producer application need to know what this looks like. And we will also have some headers. Sometimes we also get some custom headers, which are very important for the further processing of our applications. So all these things matter.
Yeah. And normally, you'd think about, how hard it is to implement two services so they talk to each other without failing. After all, as a developer, you can do this very, very easily. You can go to start.spring.io, download one package, download one thing, write some messages into Kafka, and on the other side, consume them, and it works perfectly on the first try. There is absolutely no challenges in that. And technically, yes, if you are the person maintaining both services, it might be simple for some simple cases. But normally, the services that you need to consume are produced by other teams, which involves other people, or maybe it's also you, but 6 months later, so it's a completely different you. You never know. And then the answer to that, how to make this setup work, is obviously communication. You need to go and talk to developers who develop this other service, and you have to agree what will be like sort of the protocol? What's the language that your services need to speak? What are the messages that they need to exchange? And if you have good communication between the teams, everything is perfect. However, this is very, very often the most complex part. So whatever, even if you think you have decent communication, people are different. They have own
Everybody has a bad day.
Yeah, everyone has a bad day. And sometimes like you just talk about things and then you don't realize that you actually thought about different things.
You misspell in notes.
Yeah, so communication is great, but ultimately in production it all kind of goes badly. Sometimes, not always, but you have a bad day. So communication is not enough.
Yeah, and even if we have tested it, let's think about this scenario. We communicated, we are consuming that service, we write stubs because we want to run integration tests. Why not? What can go wrong? And what typically happens is the same team will write these stubs and the same team will test against these stubs. And many things can go wrong. So in this our very, very simple scenario, what can go wrong? First of all, the topic. Really, it has happened to me to see a project that just was nearly deployed to production with a wrong topic, just one typo, and it will not work. Another thing, very, very typical for pod, just think about it. If you have ID, it's so easy to write instead in your stub product ID or whatever, service ID. In this case, UID. While if you are creating your stubs manually, anything can go wrong. And another thing, the headers. So again, if we have some values that are common, we usually won't misspell them, although things happen, but most of the time we will know how to communicate and which headers to set. But if it's a custom value, it's very easy to put the wrong thing in.
Yeah, absolutely. And as you just said, if I'm developing my service and I'm also writing tests for my service, and I'm also writing the sort of the other party for my service, a stub that will implement your service, then most likely I will not catch any of those mistakes because I'm just copy-pasting my code, or I know that like there is no chance that somebody will misspell ID. How can you even misspell ID? But like it will happen. But because it's only me who is working both on the test setup and the application and the stubs for that, I will never make that mistake. So stubs alone that you just write yourself, they do not guarantee that you actually will be successful. So we need the better approach. And what is the better approach?
The better approach is consumer-driven contracts. So we will show this to you in a demo, and we'll show some sample code. It is a concept that's been with us for quite a long time, but the implementations are mostly around maybe 10 years old. And still a lot is happening. There are no features being added to the implementation. And obviously, we are in a Spring conference, so the one I will be showing is Spring Cloud Contract. And yeah, what it will do is it will allow you to turn your stubs from kind of a wishful thinking, maybe something is happening on the other side, to I know exactly what is happening on the other side, and I can also test my application against it.
Right. So we need this picture. There are a number of concepts that you need to know, and they all play sort of the role in the process how you build your contract tests. Because you need to do several things, actually. There are two services that are involved in the contract testing, right? Like your consumer and your producer. And ideally, both of them should run some sort of tests to verify that they speak the same language. So there are multiple steps in the whole development pipeline there. And we're going to talk initially about, you're going to start with your producer. In our producer application, we'll need to enable the tests. And for that, we're going to use the build tool plugin thing. We're going to need to provide the definitions of what the API should look like. That is the contract definition. And you need to provide sort of a test setup configuration so you actually can run tests. Then the build plugin and the Spring Cloud Contract will make its magic, and then you will get the generated test that you can run, and then they will create the stubs. So there is, and then those stubs you're going to use on the other side to test the other party. So we're going to go now through all those concepts, and we're going to look at how they are implemented in the sample projects and what are the important parts that you need to know when thinking about that particular thing. So now we go to the IDE, right?
Yeah.
Perfect.
Yeah, that's...
Right.
Okay, awesome. Let's see the Kafka handler.
Kafka handler.
Okay. Okay, here it is. Yeah, so we have it.
No, this is something else.
Something else?
Right, Kafka handler.
Yeah, okay. Yep, we have it. So what is important here is we are going to have a listener in our production application that is listening for messages. 1 second, I think this is not.
It's right there. You need to bring it back. Bring it back.
Oh, yeah, okay. So we are going to show you the listener that we have. And as you see, we are going to be listening for orders. So this is...
I'm sorry. This is PowerPoint fault. Told you we should use Keynote. No, seriously, PowerPoint creates a different, separate screen. So,
okay,
before we go into there, look, it's a normal Spring application. It's a Spring Boot application, and this is the barista application. We're going to look at the producer. The barista produces coffee, right? So this is the producer application. So it's going to listen to the orders from the waiter and then implement them somehow. And it's going to listen to the orders from Kafka. So we're going to look at the Kafka handler class.
So in the handler, we have the listener that you can see, and it's very simple. We are getting orders, and once we receive an order, what we do is we are going to process it. And for this demo, the processing is going to be pretty simple. We are just changing it into a different object called serving with slightly different fields. And then we are going to put all of this into a message and send it via Kafka. And if something goes wrong, then we are going to send something to the errors topic. And that's about it. But now if we want to add the contract integration for it, we will first need to modify our POM. So let's get to it. Okay, where do we have here? This one, yeah. Okay, so we will first be adding our verifier plugin. So this is the Spring Cloud Contract Verifier plugin, and this one is for Maven. We obviously also support Gradle, so if you were using Gradle, that would work very similarly. And what we are going to do is we have a bunch of configuration options that we can set. For example, we can set JUnit 5 for our tests, and a very important thing that we are setting here is the base test class. So, in the base test class, we are going to tell contract how to exactly receive the messages. Because Spring Cloud Contract is on a higher abstraction level. It can verify REST and it can verify communication over messaging for different kind of messaging setups. So we need to tell them that what we are using is Kafka, and for the test, this is how you will pick messages from Kafka and just have them ready for verifying. So for Kafka and Spring, what is the easiest way is to have a Kafka listener. So we are adding one, and we are just going to add these messages into a blocking queue. So then the contract test, which will be generated automatically, whenever it needs to verify a message, it will just get this message from that queue that we are setting up here. So the interface that has to be implemented is this one, message verifier receiver. And I guess many of you might be thinking, like, why are we even implementing an interface if this must be happening all the time, like it's boilerplate, we don't want boilerplate.
I'm thinking that.
Yeah, we thought the same. So for now, since people are still starting to work with it and we are getting some issues and trying to improve things, we have just put it in a samples repo, and it's there to just copy paste. You can do basically that. We do have an issue open to convert it into a proper auto configuration, so most possibly in future that will be happening. For now, you just, we will show you that repo in a second, but you just pick whatever you have, let's say Kafka or RabbitMQ or whichever implementation you're using, you can copy paste it. But if you have a more custom scenario, you can also implement it yourself. So it's going to be very easy for you to customize this. And so yeah, that was the most important part of this setup. Other than that, it is just a simple class that we will use as a base for our tests. It is going to be a Spring Boot test because we want to have the context ready, and we will need a Kafka. So what is the easiest way to have a Kafka?
I know. How many of you know?
Yeah.
It's test containers.
Yep. So it's going to be very easy to just annotate it with test containers. And here we are just creating our container. And what is going to be entrusted is the service connection annotation. This is something quite new in Spring Boot, and we will talk about this more later. But another thing that we have here is some methods. What are these methods? These methods basically trigger the processing. So we have this Kafka handler process method, we've seen it. This is our actual production method. And this is what we are telling the contract, okay, you need to run this. So you need to trigger this method with an order. How do we get the order? Well, in production, you just get it from the waiter. But if you are running a test, in any test, you would have a given section where you just prepare your data. So the order we are preparing here is something like this. It's just a data item that we need to test our process method. So we are going to verify two scenarios in this demo. There is the positive one where everything works, and there is the one where things go wrong. For example, we have a coffee name that is incorrect, and we are expecting to get messages. So contract and generated tests will trigger these methods to get the message. And then we'll be able to verify if that message is really what we say it should be.
Right.
Okay. Let's go back to the presentation.
Back to the presentation. Slideshow. Play from current slide. Right. So what we talked about actually about those green bubbles mostly, right? But just a short recap. You add your build tool. Into your build tool, you add a plugin that will generate and run your tests. It's not just a test that is up there that you out of the box like write yourself. The tests will be generated for you. And so you need the build plugin for that, right? You add it, and then in that base class that Olga showed, you need to have three things. You need to set up the environment, which is create your message broker via test containers. You need to create the inputs for the tests, saying that, oh, we're going to trigger this and we're going to trigger that. And then you sort of produce the outputs by actually calling production methods, but you also give your contract tests functionality, how to verify the outputs, how to read from your Kafka on the other side so the generated test can actually go and consume those messages. Because none of the Spring Cloud contract, nor your application without the setup, nor test containers know how to actually verify that the barista put a particular Kafka message into your Kafka topic.
Yeah,
right?
so the message will be verified automatically by contract, but the way to receive this message from any given broker is something that we need to define.
Yes, you need to copy it from the samples repository into your code. And that is the samples repository, Spring Cloud Contract samples. You go, you pick your technology that you want there, consumer Kafka middleware or Proto, or if you work with Kotlin, you go into Kotlin, and you take that code and you paste it, and it works out of the box. And then for test containers, how many of you know test containers? Very good, approximately half. So test containers,
here.
Yes, we are doing good work. Test containers are the open source libraries that give you programmatic API to create, configure, and manage anything in Docker containers. Right, so you can, in this setup for the test, we said, like, give me a Kafka container, and test containers will take care of that, right? And you get the full API, so you can do this for your integration tests, like local development setup and everything. And it comes with the whole stack of predefined modules that know how to run particular technologies, right? So we didn't write like how to run Kafka in a Docker container. We said new Kafka container. That's a module from the test containers ecosystem. And the same way we can do like new Postgres or new RabbitMQ or new local stack or whichever you want. So that is that. That is the setup and the technologies that are involved. And now we get to the meat sort of this situation. And the meat of this situation is that we need contract definitions. We actually need to write down some sort of like what's the protocol for our services to talk to. right?
Yeah, we need to define the API in a way that later can be verified. So that's what we will do with the contracts. Let's do the IDE. No, nobody can see the IDE.
Which one do you want?
Now on the main screen.
Nobody can see the IDE. PowerPoint. Where's my PowerPoint? Right. This is more awkward than I imagined.
Yeah. It does work more straightforward on Linux.
Sure, sure.
Okay, anyhow, so where do you have your contracts? Well, under source, test, resources, contracts, where else? And what does a contract look like? So you remember the message we've been seeing, how the communication was defined, and the contract very much reflects it. So it's a DSL. I am one of these people that still are very unhappy about the decline of popularity in Groovy, so I'm still trying to push for it, but don't worry, you can also write it in Java, you can write it in Kotlin. If you wish so, you can even write it in YAML.
Perfect.
To each their own. So what we are going to do, we are going to define what the communication looks like. We have, first of all, our output message. So there we define that has to be sent whichever topic. It's all very similar to what we've seen, but we are using the DSL, so we get auto-completion from the IDE. We are defining what the fields should be like in the body, and obviously you don't always want to define everything explicitly. For example, for a UID, you don't really know because maybe you're assigning it randomly. So you just want to know that it has the right format and it looks like a UID. And this is one of the utility methods that contract provides, and there are many of them. Can be, let's say, any string, any date time. A lot of utility methods that will make your life easier by creating the contract. So it's not really very tedious to write. Then also we have the headers, and as you can see, again, a lot of well, here we are using application JSON, but there are a lot of other helper methods to specify things, and for the most used header types, but you can also specify your custom header here just by providing the key and value. And that's it. And when it comes to the input, this is what we write. This is where we indicate how to trigger it. So the contract will be running tests for us, and for this test, it will be triggering this whole situation. So it will be calling the trigger serving method that we have seen in the base class, where we will prepare a data with a correct coffee order. And then we will run it through our production method. So this method will be called, and we also have the label, which is something that will allow us later on the consumer side to be able to use the stubs. So we will just say, okay, give me the stubs for this label. And then we have our error scenario where nothing much happens, but the important thing is that we are covering the various things that can happen over our API.
Perfect.
Okay.
Should we be able to run this now?
Yeah, I hope so.
We have the plugin, we have the base setup, we have the contract, and we can run it.
No, can you?
What do you want?
Yeah, the terminal, let's just run it.
Let's go to Barista.
Let's go to Barista and let's run it.
And let's run it. How do we run it?
With clean install.
Clean install.
Yeah.
Okay, so we're running Maven clean install. What will happen? What will happen? The moment of truth here is that the plugin will generate the tests, taking into account our contract and our base class configuration, and it will run the tests by creating this environment for us. So it will spin up Kafka with Testcontainers, spin up our application. Then it will trigger the inputs by triggering the code in the base class that we specified, and then it will verify that on the other end from Kafka, it can actually get the message that it was supposed to get.
Okay, we have done something, we got a success, everything went fine, but what are we really verifying? What happens if our API doesn't really look the way we think it looks? Let's
Can we
try
make this test fail?
Yeah, because it's very fine, everything passed. Why do we know that we have even verified anything? So let's try to break this. And the method most commonly used for demos, let's just break it, let's disable the errors and see what happens.
So you see that this is an actual real setup here, and there is no like trickery.
Yeah.
I hope it will fail now.
We do hope so.
So now we disabled in the application logic. What we did, we disabled the error handling correctly, so it will not get the error message back to us.
Okay, just to get here to you, why are we waiting? Do we always want to wait? No, this is a timeout that you can set up in the base test class in that snippet that you can copy from our samples. We do not need to wait that much. It's customizable. But what we want to see is our test failed. Why it failed? Because there was no payload. Because we could not receive the message where we were expecting it. We simply haven't sent it since it was commented out. And why? And even what is this test that failed? Contract verifier test validate should send error. Because I have not certainly written such tests. So it is the contract that has generated it. So you find it in the target under generated test sources, and here's the test. So what it will do, why we needed the base class, because every test that was automatically generated for us will extend that base class, so we'll have a possibility to call methods from that class. And then what it does, it triggers the trigger method defined in the input section of the contract. Then it tries to get some kind of message using that implementation that we've provided, and then step by step it verifies that the message is conforming to the contract that we created.
Yeah, so you don't have to write all this. They will be generated, and you just provide the basic building blocks.
Yeah, because if I write a test myself, there is this kind of confirmation bias. Well, sometimes I might try to make test pass, even subconsciously, or I might forget about something, but like this, we know for sure what is in the contract is going to be verified. And once it has been verified, it creates stubs, and we can see that in the logs of Barista that we have done this before.
Wait, we need to
run it again. No,
okay.
it's, okay.
We fix the application, we run it again, and then we are testing the producer, and the producer will be like, the contract test will say, yeah, the producer produces the correct messages.
And you can see now that we have our artifact, so whatever we would usually install to our Maven repository, but we are also installing another artifact with a stubs classifier, this jar here. So this is here obviously happening locally, but normally if we had a deployment pipeline, we would have deployed the artifact to our artifact repository, wherever we keep them, and we would also deploy the stubs jar to the same repository. And then any application that is our consumer can download this jar with the stubs and can run all their integration tests for the API integration against that jar. So against stubs that are no more wishful thinking. They are actually guaranteed to reflect the producer.
Yeah, should we look at it?
Yeah, let's do this.
Let's look at it. So here's our waiter application. And our waiter application is also very, very simple, right? So it's a Spring Boot application. But the interesting part here is that on this side, we do implement our proper integration tests. So if I look at this, waiter application integration tests, besides the normal Spring Boot test annotations and configuration annotations and what to configure, we also say that we want to have the auto-configure stub runner that will work for our Barista service, and we're going to take it from our local Maven repository.
Obviously in your pipeline, the mode would not be local. It would be set to the appropriate repository.
Yeah, but because we only created those jars locally here, we're going to use them from the local thing. And then what we can do is we can write our full integration test. So we're going to have, remember, this is the waiter. So given that we are sending the required HTTP call to our waiter application to produce the orders, we can run that using, we are currently here running it with rest assured, but you can use whatever framework or method of triggering as you want. So we do that, then we trigger our stub. And in the stub, we are saying that please trigger the scenario that was labeled as serving.
That's where you use the label.
That's the label from the contract. And then the stub will do whatever it needs to do. It will go into our Kafka message. It will look for our order message that our waiter allegedly generated when we triggered it. And then it will take the stub response that was verified by the contract, and it will produce that. So on the other side of this functionality, we can actually wait for our waiter to go get the response from Barista and then do whatever it needs to do. In our case is just we are waiting for the logs for our service to contain the output of this whole operation. So this becomes a proper integration test that where we're going to run our service with our Kafka in a test container with the stub of the barista and the flow that goes through the whole way, right? We generate the message, we generate HTTP request, the waiter puts the message into Kafka, then the stubs happen, the other message appears in Kafka, waiter needs to take that and then do something, in our case, write the logs, and we can verify that. And we can run it. We don't have anything else. We don't need any other configuration. We can just run it. And it will work the same way. It will create our Kafka message broker properly with test containers. It will run the stub as the jar file that we deployed, and it will run all the tests.
And it passes even though the other application is not running anywhere. So it's all just taken from stubs, and you don't only have to use this for REST. You can use it for messaging as well.
Yeah, you can, in your REST case, of course, you wouldn't need your Kafka, and your communication probably would be simpler, but you can do that for any complex patterns of communication. And what is even better, I think here now, what we need to do, right, let's recap. Shall I recap very quickly?
Yep.
Right. A very quick recap. So we had the contracts that defined our protocol, what our application should speak. We had our contract that could define which topics you want to communicate with and which the body of the messages that you're going to expect and how to actually trigger those responses from the producer and the additional headers. So that allowed us to generate those generated tests that we can run on the producer side. And when the tests pass, then we create the stubs automatically from those tests.
So those two steps are done for us automatically. We take care of the first 3 steps, and the others just get done.
Yeah, and then that allows us on the client side, on the consumer side, to write proper integration tests against those stubs. And there is no chance that you will mistakenly implement the stubs the same way you implemented the client, because, well, they come from the verified producer. Right, so that was on the consumer side, we run the tests. So now what is even more interesting, and this is what we thought of talking here a little bit about this.
And this is a new feature in Spring Boot and Testcontainers application.
Right, this is coming back to that annotation, which was the
service connection, one of my favorite annotations now.
Yes, oh, thank you so much.
Because before you would have to create Docker Compose. I don't know how many of you like to create Docker Compose files to run local development. Well, I don't, and now I don't have to.
Yes, so how do we create Kafka for this service? We use the configuration from the class called container config. And this is new, this is it's since Spring. Thank you. This is incredibly frustrating feature of PowerPoint. Should we even show any slides anymore? Probably not. So,
just at the end, yeah.
So in our application, we can create a class that will encapsulate our configuration for the containers. We will write the methods that will return test containers abstractions, like a Kafka container or your Postgres container. We're going to slap a bean on them, so Spring Boot will know that those are the things that the application needs to manage the lifecycle for. Right? You don't need, there are no calls to start this Kafka, and yet Kafka somehow starts. This is the integration between test containers and Spring Boot, and the service connection will allow Spring Boot to go into this Kafka container and configure the application to use that Kafka instead of anything else.
Yeah, and before some of you might have been using dynamic property source to get data from the container and then pass it on to Spring Boot, but it was more complex. Now Spring Boot is doing this all for you with service connection.
Now it's just 4 lines of code, and short ones. And besides just running tests, you can also now use it for your local development mode, which is where you can create the application in your test sources, and you can say, I want to run my actual application, but I want to run it with my containers, and then you can just run it. You run this, and your application will start. There are no Kafka provision here, but the Spring Boot will take into account the containers config, create one Kafka for you using test containers, and your application will actually run locally. So if you want to run it locally and verify that it works, or if you want to work on it, you can embed that configuration there, and you don't need to do anything else. And nobody else on your team has to do anything else to get this set up. It's just like they need to run your application, and the containers will be there for them. So, and it starts, and it works, and you can do even more complex setups. Yeah.
Yeah, okay, so now let's...
Right. And what I wanted to show here, is, incidentally, by a happy coincidence, just today, AtomicJar released a thing called Testcontainers Desktop, which is a little application that helps you work with your test containers setups. And it's a tool that enables you to work with it more efficiently.
And can I download it for free from the site?
Yes, it's a free application. You can download it, you can run it. It simplifies your work with test containers. You can freeze your containers, so after the test, they're not cleaned up automatically, and you can inspect your state. You also can have the proxies, stable proxies, to the dynamically created containers. So for example, if I run my Kafka, I want my local port to always proxy to the particular Kafka instance, irregardless of what higher ports the default test containers configuration have created. Because the dynamic ports are good for integration tests, allows parallelism, allows to avoid collisions, but for your local development setup, having a stable bookmarked proxy, it's much, much easier. And you can do that very easily with the Testcontainers Desktop app. And there are more tooling enhancements that will be happening there. But currently, if you are using test containers, I encourage you to go to testcontainers.com/desktop and check it out. Right? It's pretty good. Right, so.
We will not be switching again, yeah? This is the last switch from ID to slides we are doing. Thank you for, for staying with us throughout these ordeals. And what we will talk about is, other than a simple dev environment, is more about how teams can actually use contracts in practice. So there are various approaches to working with contracts. First of all, you have provider contracts, and this is an approach where contracts are with the producer. The producer has no knowledge on how the consumers are using them, and the producer can possibly impose contract changes on the consumers, which is, well, up to you to decide if it's good or not. Another more common scenario is consumer contracts, where the contracts are with the consumers, but producer doesn't track them that in a detailed way. So, for example, consumers can have different versions or want different versions. There can be conflicts. Or, in some implementations, consumers can break producers. Do we want this? Some people want this. But what we think could be a better way is consumer-driven contracts, where contracts are either with the producer in the same repo, or sometimes in organization where they are not allowed to share repos that can be in a separate repo altogether for contracts only. And the consumers contribute through pull requests to that repo or to producer repo, asking for a certain contract. And then producer knows exactly who and how is using the contracts, and the contracts is the API. So who and how is using the API, and which fields are being used, which are not being used, which is, again, very useful, because maybe they realize nobody's using some functionality, they can actually later remove it. So what is our flow that we imagine and that is inspired in open source work that we do in working from pull requests with people from all over the world that even don't know each other. So we believe that teams which are located together and know each other can also definitely do it. So the consumer checks out the contract repo or the producer repo directly, and then what they do is create a pull request with a new contract. So they're proposing, okay, I want a new endpoint. This is my contract, please create this endpoint. So what happens? The producer obviously has to review the PR, and as it reviews the PR, they have a lot of say on what is happening. Maybe they will say, okay, no, there's no way, we are not taking in this feature, we are not adding this to the API. Or maybe they will say, okay, but this field cannot be named in this way. Or maybe some other consumer will join the discussion in and will say, you know what, we were also thinking about something like this, but we need this to be slightly different. And they discuss this. And then, hopefully, at some point, they can agree. And the producer says, OK, I like this contract. I want to implement this API. So first they run the build on the PR branch and says nothing has been implemented. It fails. Then, obviously, they have to implement the required API changes. Then they can run it. It will pass, so they can merge it to their main branch, and then it will get deployed. Whenever we generate our artifacts, we will also generate stubs jar in our deployments.
Right. So essentially what happens is that the contract tests enable you to sort of productize the communication between the teams. You know that there is a certain process that you need to go through when you want to add features or remove features, and that process accounts that you will run automated tests, and it doesn't allow you to kind of sort of implement something by yourself without talking to anyone.
And also this is very important, because sometimes if people are working and you start building API from producer side, often it ends up being not very usable for the consumers.
Yeah.
So the consumers usually know much better how they would want to use an API and which API would be more practical for them.
Yeah. And with contract tests, you have the approach for communicating that. Just a moment, the last thing is, if you want to evolve your services, right? You would like to also test against probably the new version that will be deployed soon, so you verify that both parties communicate correctly with the new version, but also which is currently in production, because you don't know which one you will deploy first, right? Will you update the clients first in your clusters, or will you update the producers? And very easily you can achieve this setup, because remember, the configuration for what stubs to test against, that was just like a version in your profiles.
Basically you very simply can add this to your profile and just specify, I want the version of contracts that is currently in my production.
Or you can say, like, I want the latest that will be deployed next by that team, and then you can specify and verify that your application works with both, and then you can have the safe evolution. And eventually you're gonna deprecate some of the APIs, so contracts, and then you can move forward. So with that all said, thank you very much for coming, and stay connected. Don't be strangers. Follow Olga on Twitter. Follow Oleg on YouTube. Smash that subscribe button. Just kidding. You can, but you don't have to. And Testcontainers are at testcontainers.com. Spring Cloud Contract are a project at spring.io/project Spring Cloud. Their application that you've seen here is available at that GitHub URL.
Yeah, please take a look and let us know what you think about this.
Yeah, and if you are here the whole week for the conference, AtomicJar is sponsoring, so if you want to talk about test containers further, not just for contract tests, but integration tests or anything, please find the booth. We are very small somewhere in the corner, but if you are patient, you can find us, so please do that.
Yeah, please take a survey if you can.
Take the survey. If you like the presentation and if you want to say good things, definitely write that in the survey. If you think we can improve dramatically, please give that feedback to us personally. I'm just kidding. You can write there anything you want. Anything you want.
To improve it, yeah.
Anything you want, you can put it in the survey. We'd be happy to read your feedback. Thank you for being with us this morning. Thank you very much. Have a lovely conference.
Yeah.